So you did great, huh?
Um,
What? It was easy, wasn't it?
um,
You know, I think you always overthink it. It's just simple answers. Don't overthink it. Okay, again, don't worry too much about it. This is Braden done? Okay, Braden is not done. Don't think too much about it because you still have the final, lots of lab reports, and again, it's equivalent to a full lab report. It's good practice to study and prepare yourself for the final. Good. All right, so I'm not going to do a recap question because supposedly you studied this lecture. We stopped here. We were talking about the current status of lipid oxidation. And now we're going to talk about evaluating oxidative stability. So there are 3 common tests that you can do to determine the oxidative stability of your oil. Sometimes you do that just to look at the stability of a particular oil. Sometimes you do these experiments to look at the efficiency of utilizing antioxidants, let's say synthetic versus natural or new antioxidants. So you use some of these methods that are often accelerated shelf life studies. So basically, we determine the oxidation over time, but we accelerate the time so that we don't have to do this for months. So we put it under elevated kind of conditions. We put the oil under elevated conditions. One thing I want to define is the induction period. So what it means is the time before a noticeable spike in oxidation occurs. From 0 time, that means as fresh as you can get the oil, then you put it in under accelerated storage, and the time that you see a change, that is called the induction period, whether it's 2 days, 3 days, or whatever it is, or hours, depending on if we're doing accelerated storage. That would be the time it takes to get to a first detectable oxidation. There are 3 tests that are very commonly done. The most common one is the oven storage test. So similar to the trial that we did for you for the lab, but that was super accelerated. It was only for a few hours, so we had the temperature really high for the oven. But the regular oven storage temperature is between 60 to 80 degrees. And we store it over probably up to 10 days of storage. And then you would take samples every 1 or 2 days, and then you measure lipid oxidation. You can do that by just measuring peroxide value, or sometimes they do peroxidase and N-acetylene value to get Totox. So if it's a very fresh oil, you can go with just a simple peroxide value. Oil stability index, this is another common method. Also, you have an equipment called Ransimat specific for that. What you do is you get your sample oil, you bubble through it air, and then volatiles are siphoned into another flask. Usually you get volatile acids when the onset of oxidation happens, and volatile acid goes into a flask and measure conductivity. Once you see a change of conductivity, then you have oxidation start. Another one is oxygen bond. So you put your sample in a chamber, you pressurize that chamber with oxygen, you seal that chamber, you put it in a boiling water bath, and then you measure pressure. Whenever you have a sudden change in pressure or reduction in pressure, that means oxidation started, because oxygen is taken up when the oxidation occurs. So these are 3 methods. Sometimes in an exam, I ask you to give me one method. You whatever you want to remember, you can remember, and just explain it in terms of how it works. All right, so the next one here I want to talk about is the characterization of the different components. So finding fatty acid composition, and then calculating unsaturated versus saturated fatty acid. Determining mono, di, and triglycerides and phospholipids. These are usually done using HPLC methods. Cholesterol, and then lipid-soluble pigments and vitamins, also done by HPLC mostly. So fatty acid and cholesterol are done using GCFID or GCMS. Fatty acids, same principle that you have done in the lab with the FAME. And then for cholesterol, when you have your lipid extracted, you want to get the non-saponifiable matter. The non-saponifiable matter is cholesterol. So you have a question for the lab report asking you about the non-saponifiable matter, and that is cholesterol. So if you take the lipid fraction and saponify it, cholesterol will not be saponified. Then you will have fatty acid salts in your aqueous, and cholesterol will remain in your organic solvent. So you separate the aqueous, you don't methylate here. So it's just saponifying with, let's say, sodium hydroxide or potassium hydroxide. Then you get fatty acid salts, they remain in the aqueous, and the cholesterol remain in your organic solvent. You evaporate the organic solvent, you derivatize the cholesterol to make it volatile and thermally stable, to run it using the GC. The last thing I have here is running, usually it's very common qualitative method is the thin layer chromatography, where you run your sample and you run standards and you can determine if you have phospholipids, monoacylglycerol, diacylglycerol, fatty acid, or triacylglyceride. And that's your sample or different samples. So it's a very qualitative method that you can use to screen the composition of your lipid in your samples. Okay, so this, how tired are you? Do you want to start anew? Please stop. Okay, wait, I have 5 minutes. I want to show you something funny, but I'm gonna first stop sharing here, and I'm gonna stop recording.